All right, here we are on day 2. Cube conundrum. I was terrified this was going to be like cube geometry, but fortunately, so far, at least it's not. Let's get started. So we have a game here, or rather, we have a number of games, and I believe my interpretation of the problem is each game. Yeah, what does it say? Each time you play this game, he will hide a secret number of cubes of each color in the bag. So each game has a different number of underlying cubes. And the elf will show us, grab some cubes out of the bag, show us, put them back in. Here, put them back in, grab some more out, show us, put them back in. So we've got here a list of games, and then inside each game, there is a list of rounds, let's say. Rounds and a set of cubes within each round. And our job, which is uh, a troublingly small amount of the possible problem, we need to work out if there are this number of cubes of each type, which games would be possible and which would not. So in this case, 1 is possible because we're not shown more than 12, 13, 12 red, 13 green, or 14 blue. Whereas game 3 would be impossible because at one point we're shown 20 red, and there can't be 20 red if we've only got 12 red cubes. And our job is to work out which games would be possible. So in principle, in theory, there's the troubling phrase. In theory, this should be nice and simple. What did I call these? They are in the wrong collection as well. Oh well, anyway, deal with that later. So we've got this, and actually, let me use a better feature. Let me do that. I've got them separate, and 1, 2, and 5 are possible. Make those green, and 3 and 4 are impossible. So let's make those red. Well, sorry, actually, if you're red-green colorblind, it's not going to be that helpful. I don't know enough about colorblindness. Let's leave this black. So green is good, black is impossible. And this is in the case where we've got, that's my input, where we've got, move these over here, go to my slacks. Actually close those. It's no good. Don't want those in there. All that. Close that as well. All right. Okay. Yes. 12, 13, and 14. So if we're designing an algorithm for this, then let's say we've already done the parsing, so you don't need to worry about that. Well, we will need to worry about it at some point, but you go away. Let's say we'll figure out the parsing at some point, but we want to go through each game and each round. So let's say we start off with this game. And then we start off with this round. And we want to check, are there more than 12 red cubes? No. Are there more than 13 green cubes? No. Are there more than 14 blue cubes? No. In which case this is possible. We move on. Does it break our rules? No, we move on. Break our rules? No, we move on. So this one ends up being a tick. So we move on. Does this break our rules? No, no. Anyway, make that, put that back. Does it break our rules? No. So this one is a tick as well. Now this one should fail. Okay, this one, does it break our rules? Yes. Therefore, this one is a no. So we can short circuit at that point. Okay, this one, does it break our rules? No. Does it break our rules? No. Does it break our rules? Yes. So this one's a no. And down to this one. Does this break our rules? No. Does this break our rules? No. So this one's a yes. So the result is 1 plus 2 plus 3, or rather 1, 2, 5, which is 8, which is the correct output. Okay. Seems straightforward enough. So algorithm is for each game, for each round, does it contain more than 12 red? Game failed. Impossible. Does it contain more than 13 green? Mark game impossible. Does it contain more than 14 blue? Impossible. Otherwise, mark game possible. And then sum of IDs of games possible. And probably we want to parameterize this as well. Okay. So let's go with, let's see if I can use my, oh gosh, again, nightmare. I swear there's like a thing in control of my hand which just makes me put the wrong keys in sometimes. So let's have our functions. And let's actually use our state this time because I need to remember how to use that tool. The state is X. Do you want to capture them separately? It's a dict of string to ints. Possible games, possible game IDs. This would be a list of ints. We don't need to visualize it really, don't think. Okay. And then the functions, we've got to have a parse, we've got to have a calculate, parse line. And then we've got to have a is possible, is round possible. So the is game possible should be, this should take, well, actually, this is a good point. How am I going to model this? Do I want to have an object to represent a game? No. Be kind of annoying to keep track of everything otherwise. Okay, let's go with the game and let's have it have a ID round. Let's store the games. ID and around. And around is going to be a list of let's go with that. This should be a game, and this should be a round. And a round is actually a round is a dict. Yep. I'm not sure I like the dict. I mean, I'm sort of gold plating it, but it's less room for error if I do this. Okay. Yeah, because I'm going to try and see if I can remember how to use this before it becomes really troubling. Okay, great. Great. So plan of action. Okay, that should work. Gonna have to remember how to use regexes as well. Okay. And I just need to refresh my memory on how to use data classes as well, because I always forget syntax. Great. Yeah, there's this thing, isn't there? Yeah, very annoying. Yeah, and then when you create one, yeah, you get to give it all those things, right? Yeah. Okay, great. All right, I'm definitely taking a slightly more gold-plated than necessary approach, but I do want to remember how to use this stuff. Okay, great. Now let's see, that shouldn't be locked, causing all kinds of chaos here. Okay, trial in here, and the real one, which is, by the way, not too long. Yeah, it's kind of it gives me a slightly troubling feeling that it might get complicated later, but it is only day two, so probably fine. Okay, let me get my plan up. All right. Let's go. Go. Already forgotten that syntax. Okay. From data classes import data class. We're going with a round first. That's the right syntax, right? Oh, yeah, I should run my. Right in the wrong directory. There we go. Okay. And then round is a list of rounds. No, wait, that's not right. Already got that wrong. Okay, round is blue int, red int, green int. There's it. Default factory. Import that as well. Okay, that's cubes. Let's this is like a round technically, right? No, I'll take that as an argument. Uh, okay, odd. No, forget about that. Possible names equals list. Same thing here. Hey, and there's somehow some sort of function on it. Oh yeah, I forgot to do this. ID for index for, let's make that not reserved word. Index for game in state possible games. Great. Okay. Possible games is going to be game. All right, now if we put this in, this should give us 3, right? I could import that. Okay, we're good. All right, that's good. That one's fine. Evaluate, I'm going to start with evaluate round, actually, not evaluate game. So evaluate round is state and round. And we want to say state x cubes blue is round is greater than this, return, let's say, false. I'm going to rename that because I'm actually going to make it not alter the state. Okay, it is greater than, right? Yeah, otherwise return true. Okay, round possible. Go with my state, and we have this here. And then the round of 1, 2, 3 should be true. Okay, and it is. If it's 2, 2, 3, it should be false. It's 1, 3, 3, it should be false. If it's 1, 2, 4, it should be false. We just yeah, fine. Okay, so it is working. We should rather checks first next time. All right. Def evaluate game. Okay. Any if any is round possible. Do we have that? No. Anyway, if any not round possible is round possible in game rounds. What's wrong here? Getting myself upset. Okay, is round possible state round or round in game rounds? Yeah. If I can do this. Okay. Do we have a none in Python? It's all, isn't it? That's the inverse. If all is round possible, then state possible games depend game. Else okay. Let's do that. Okay. So I'm going to evaluate the state with a round with a game like this. Possible games. Should fail. Okay. Actually, I can do this straight out, I think. Gosh, I'm rusty. Yeah, there we go. Oh no, we can do it literally here. Great. If we try it with a impossible state, rather, if we try it with one round that is not possible, then we should see this game not in the possible games, but in the impossible games, which we do. All right. Def, all right, what are we doing? Def pass line. We evaluate the game, great. Okay, now we need to pass the line. Okay, and what we've got here is okay. For RE. Okay, and it is game digit plus colon. Now this I want to have as a this is going to be irritating. Okay. Rounds. Let's go with just rounds. Okay. Next should be matches group 0 to derized. Okay, so check this line. Let's go with this one. Two. Okay, is that true? No. Is it one? One indexed? So, okay. Now rounds can do with RE split. Group. Two, and what is it? Split by the pattern. It's actually a semicolon. Okay. Green, blue. Okay, they're not always in the same order, which is extra fun. Oh, no, they are actually. I don't want to assume that. Okay, okay, so let's then say all round in rounds. We want to then split by comma. Then, in fact, we could, no, let's split by this. Okay, and print by the counts. What's going on here? Okay. They are awful. Now, can we destructure a sign in this way? I don't actually know. Count and color. We can. Okay, great, finally. All right. So our Gosh, I'm taking my time with this, aren't I? All right. Okay. So now okay, so this should be, what is it? Blue, red, green. Blue, red, green. 1, 2, 3. Oh wait. 1, 2, 0. Blue, no. Blue, red. Okay. All right. Blue, red, green. Round here should be 4 blue, 0, 1 red, 3 green. Round here should be 1 blue, 0 red, 1 green. Is that right? Yes. Okay. We're getting somewhere. All right. Back to the plan. What's the number? 12, 13, and 14. Nope. 14 blue, 12 red, 13 green. What is it again? Every line. They can be run at this point. This and this estate. This line. What that. This needs to return a state. What's this supposed to get? State line index. Okay. It has something in it. Oh yeah, you're eight. All right. Print. What is it? Some possible game IDs. Eight. Okay, great. Now let's try with the input. 2176. Is it right? Yes. Okay, that's 2438 or thereabouts. So a gold run. I did say I wanted to learn how to use my framework again, and that is definitely happening. Okay, part two. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source. Just check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Again, consider the example games from earlier. The power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game one is 48. Games 2 to 5. Yeah, okay, adding up. Yeah, fine. So that's what we calculate. Okay, fine. So it's the minimum of each, right? Game one. Okay, let's try this out. So minimum blue is 6 here, right? Minimum red is 4. Minimum green is 2. So the power should be 6 times 4 times 2, which is 48. Is that the right power? Yes. Okay, let's try game 3. 3. This is game 1. Game 3. Uh, blue. Okay, 6, 5. Okay, blue 6. Red is 20 red, and green 13. So 6 times 20 times 13, 1560, which is indeed the answer. Okay, fine. So in which case, we've got some code to go through each game. We need to swap out is round possible. Yeah, okay. So instead of is round possible, we want to have a minimum cubes for a game. Okay. And we also want to have on round, we want to have an extra method, which is a game. No, yeah, round. We want to have a power. So this should return a round. Don't think we need the state there. Okay, this should return a round power, and then we need a some powers. Minimum cubes algorithm has to go through each round. So let min red, min green. In fact, we could probably use something like that for each round. Mid round is something like round min. Something like this, that sort of thing, etc., etc., etc. I can probably put this on game. Now I think of it. Yeah, seems fine. Okay. So plan of action is implement minimum cubes, implement power, implement some powers. Yeah, and then we should be fine. Okay, let's get started. There's this, start this going. All right, I reset the timer. Okay. Stop these running as well. Get rid of that. Okay. Probably could be using these objects more as well. Okay. 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 So in with the rounds Let's go with game 3. Queen 8. Sure, we've got another one here, don't we? Yeah, let's go with game 2. Fine. So game 2 should be 12. Hmm. Well, actually, it should be red 1, green 3, blue 4, because we're not calculating the power yet. So have I gotten this wrong? Oh, this needs to be some sort of ridiculously large number, right? No, wait. Again, I've missed something. It's not the minimum. It's the maximum. It's the maximum. Yeah, okay. Great. Oh, great. Okay. And then I don't need this anymore. But we do want to go through getting real mind blank here. We do want to go through, yeah, we do want this. And we do want to go through and calculate the power Yeah, so we're going to alter the state and we're going to say sum powers game calculate vanilla cubes power. We want to print out all right, that doesn't look right. 2286, that's true. That's correct. All right, now if that one's correct, be done. Okay, good. All right, again, just sort of let me switch back to my code. So what I'm kind of what I'm concluding, oh yeah, the time. Oh, it's like eight minutes. What I'm concluding is that I did want to get to use this framework again and figure out all the different pieces that I built last year, but they are definitely so I think I built the framework around the point where um, things started to need like calculation that was beyond it was sort of very big, like you can really reason about it like you can these problems. So I needed, visualization stuff. I think it's probably overkill for this, and actually, realistically, this is probably the most annoying part of it, parsing the input. Um, so again, I probably made it more complicated than necessary for myself. But it went all right. I think tomorrow I will determine. So one of the reasons that I write things in this way is I'm trying to one minimize any sort of fancy stuff. So with this, for example, like I could have chained these with an and, but I want to be a bit more explicit so that I would make fewer mistakes. And then uh, I noticed, I think, as the challenges went on last year, that I would have a problem regularly where I would be passing around I'd be calling all the right functions and stuff, but then something deep in the function stack would need a new bit of information, and it would cause all kinds of problems for me then refactoring. So I essentially went with global state, which is what the state class is really about. But it doesn't really work for these problems. It's not really necessary, and it kind of adds a bit of complication. Like, why not just return stuff? I think probably the right way to approach these is to put things more on the objects being worked with. Um, and then you can move state around up to the global layer if you need to. Parsing was also now how really should I have done that? There was some sort of complexity in the fact that they could have different they didn't have to specify all of the cubes. So that was sort of annoying. I could have probably done a fancier regex to deal with that, but I erred on the side of stuff that I knew I wasn't going to get messed up on. So I did it this way. Anyway, fine, all got it done in the time, so that's the main objective. See you tomorrow.